Y'all, what's the root of just plain 36? Right. So the root of negative 36 is 36i. So there's already a number down here, so we're going to multiply these. So the root of negative 36 is 6i, and we just multiply. So 3 times 6, that's just 18, and then don't forget the letter I. So real and imaginary numbers can be multiplied. All right, let's go ahead and take a look at number 4. Number 4 is the root of negative 20. So there's a perfect hiding out in 20. 4 times 5 makes 20. And I'm choosing 4 and 5. I'm not choosing 2 or 10 because neither one of those are perfect. 4 is perfect. We're going to yank that 4 out by its root. What's the root of 4? 2. Yes. But remember, it's a negative 20, so you have to take an I out at the same time. So this simplifies to 2i root 5. Any questions on that? Okay. Y'all, above problem number 5, write like terms. Remind yourself that's an example for like terms. Also, I'm going to share with you the rest of this. What does that stand for? Do y'all remember? Order of what? Thank you. So this is like baby order of operations. Here's the 2 pieces that are missing that you need to know. So what that stands for, if there's any roots, you got to simplify your roots. If you have any imaginary numbers to an exponent, you got to clean that up. Then you do your regular order of operations that you learned in junior high or whatever. All right, so we got some roots over here. I cannot do anything until I take care of this. Oh, there's that 20 again. Y'all, what's the other piece that makes up 125? 25 times what? All right. So the first thing that we're going to do is we're going to simplify these roots. Y'all, please remember these numbers are getting yanked out by their roots. They are also negative, so we have to take an I with it. So I'm going to recopy this problem. I'm going to go ahead and copy the 6 there. Then I'm going to multiply by what I'm taking out. Remember, we're taking that 25 out by its root. Remember, it was negative, so I'm going to write 5i. The only thing that's remaining is just a 5. Now I'm going to copy the rest of the problem. I'm going to recopy that minus sign. I'm going to copy this 5. That phone can ring out. What do I take out? What's the root? Don't forget your letter I. Miss Harrington just made someone mad. I don't care. I'm here for y'all. All right. So, roots done. I's, they're what, Ninny? Parentheses, there's none. There's no exponents. Y'all need to multiply the 6 times the 5i. This is Maria. Yes. Sure. That's you, sir. You get to sign out. They need you to stop by attendance.
All right.
Thank you. All right, so we do have multiplication. So, guys, you're going to multiply these. Can I multiply a real number times an imaginary number?
Yes.
Yes. It's not always the case for all of the operations. So this is 30i root 5 minus 10i root 5. And then what did you write right above that problem? What 2 words did you write? Like everything has to be right. By Jeremy. The radicals have to be the same. And if one of them has the letter I, they both have to have the letter I, or you can't do it. Do they both have the letter I? Yes. Do they both have 5 for a root? Yes. So y'all, it's just 30 minus 10. It's just 20I root 5. Any questions on that one? Okay, so look at this. This is not in your packet. This is just an example. We have not done anything except pure imaginary numbers. All of your answers that you and I have boxed in have had an I. They are pure imaginary numbers. Now we're about to do some stuff that have real with it. Real and imaginary numbers, you cannot mix them. So that's called a complex number. It's made up of a real part and an imaginary part. Your real part always comes first. So let's go ahead and take a look at this example here. And then remember, real and imaginary cannot be combined. We're simplifying roots. We don't have a root, so I don't have to do that. Do we have any i's to power? No, we don't have to do that. We do have parentheses, but can I do anything inside those parentheses? Nope. No exponents, multiply. There's one thing you're going to multiply here. The negative. Great job. Y'all, let's distribute the negative. So on the next line of my work, I'm going to distribute that negative to everything here. So it's going to be negative 6 plus 8i minus 3, then what? Plus 5i. Write that down. Thank you. And then y'all grab one of your highlighters. Grab your highlighter. So what we're going to do with one of those highlighters is we're going to highlight the real parts. So take one of those colors and highlight the real parts with me. And then take the other color and highlight your imaginary. Real part first, which is what I highlighted in yellow. So this is going to be a negative 9, and then your imaginary part goes at the end. Y'all, it's just 8 plus 5. So it's just 13i. Any questions on that? So remember, it's always this. Do we have a root on number 7? Oh, yes, we do. Y'all, that negative 49 should be flashing off the paper to you. All of you guys should realize that's a perfect square. What is the square root of 49? So just put an I next to it. That's it. So I'm going to start to recopy the work. And then instead of that root negative 49, I'm just going to write what it simplifies to, which is 7i. And then we don't have any i's to any exponents. We have parentheses, but we cannot do anything with that. So we're going to go straight to multiplication. We're going to distribute the negative again. And then, guys, let's highlight our real and our imaginary. So this is my real part. And that's my imaginary. And remember, real goes with real, imaginary goes with imaginary. So all we're going to do is do 31 minus 2, which is 29. And then tack on that 7i at the end. So we simplified those i's with exponents. I'm going to bring everything else down. I'm just going to make sure my work stays aligned. So I'm going to recopy this 5. I'm going to recopy that plus sign. I to the 5th turned into plain I. Plus 6 minus 2 times that negative I. So finally we're on a level, guys. This might be level 1 because of this right here. What is a negative times a negative? You have to change that to plus 2i. You have to change that to plus 2i. So here we go with our work. Again, it's going to be 5 plus I plus 6 plus 2i. So if you could, take the cap off that highlighter, highlight your real and your imaginary, and then we'll combine and start moving higher on these levels. All right, just remember your real part goes first, so the 11 has to go first. So it's 11 plus 3i. The solutions of an equation, somebody solved an equation and they got 2 answers, which makes sense because it's a quadratic. It's 6 plus I and 6 minus I. And we're going to find the sum of those solutions. So 6 plus I plus 6 minus I. So let's just add them. So I'm going to highlight my real part. And then I'm going to highlight my imaginary part. And y'all, what's going on with his eyes? They cancel out. It's going to happen a lot. Whenever they're weird looking, when they're not plain numbers, 9 times out of 10, they're going to cancel out. So the answer is all real, just a plain 12. That's it. Okay, let's take a look at the next one. Find the sum of the solutions of an equation if the solutions are 5 plus 3 square root of negative 20, 5 minus 3 square root of negative 20, and we're going to add them. So 1 root is here, 1 root is here. 1 root looks like this, or one answer. Does anybody know what the other one is? Yeah. Yeah, same thing. It just has the minus with it. Good job. So remember, before we do this, we have to simplify stuff. I think this is going to be the 3rd time that we've simplified the square root of 20 today. What perfect is in 20? We're going to yank it out by its root, which is a 2. And it's also negative. So it's going to be 5 plus 3 times 2i. What's in there? It was 4 times what?
5.
And then this is going to be 5 minus 3 times 2i root 5. Let's kind of clean this up a little bit. So it's going to be 5 plus 6i root 5. So I multiply the 3 times 2i because I can multiply real and imaginary together. I just cannot add them. I'm going to highlight my real and my imaginary. What do you guys notice about the imaginaries? Same thing as problem 9. They cancel out. So the answer is real here again also. It's just a 10.